Coefficients. In a chemical equation, we have two sides to a chemical equation. We have the reactant side and the product side. So for example, on the reactant side, we have hydrogen and oxygen, and on the product side, we have water. The way we read this is that we have 2 mole of hydrogen plus 1 mole of oxygen yield 2 mole of H2O or water. So that blue arrow is the yield. Let's take a look at the chemical equation and see the different parts. Now on the reactant side, we see that we have H2 and O2. Those are the reactants. So, reactants, H2, O2, reactants. Now on the product side, we have H2O. That is the product. So in front of each of the reactant, H2 and O2, we see a number. This number is called the coefficient. It indicates the number of mole. So for example, in front of H2, we have 2, which indicate 2 moles of H2. And if there is no number being indicated, like in front of O2, that actually represents a 1. So therefore, there is 1 mole of O2. On the product side, we see that there is 2 mole of H2O, so there is the coefficient 2. So each compound is made up of elements, and there's a number next to each element that tells you how many atoms of each element there is. So for example, for hydrogen, you have 2 hydrogen. So that's the subscript. And for oxygen, you have 2 oxygen. Over in water, water is made up of 2 hydrogen. And since there is no subscript here, we read that as a 1. I'm going to write a 1 here. And we read that to say that there is 1 oxygen. So there's a subscript 1 there. Let's take a look at this example. We have here a chemical equation in which we have 2 sides. We have the reactant side and the product side. So our reactant is AlBr, 3, and K. So this is our reactant. And our product we have is KBr and Al. So this is our product. So on the reactant side, we have 2 reactants. We have AlBr3 and K. And we can see that we have 1 AlBr3 and we have 3 K. On the product side, we have KBr and Al. And we can see that we have 3 KBr and 1 Al. These are our coefficients. For AlBr3, we can see that the compound AlBr3 is made up of 2 different elements. We have aluminum and we have bromine. And we can see that we have 1 aluminum and we have 3 bromine. Similarly, we can see that K, we only have 1 K. Over in the product side, we see that we have 1 K and 1 Br, and we have 1 Al. So those are our subscript. So what does this really mean? It means that for the reactant side, we have 1 mole of AlBr3 and 3 moles of K. And on the product side, we have 3 moles of KBr, and we have 1 mole of Al. This 1 mole of AlBr3 consists of 2 elements. We have 1 atom of aluminum, and we have 3 atoms of Br3. And this 3 mole of KBr consists of 1 atom of K and 1 atom of Br. Let's take a look at this chemical equation. In this chemical equation, the reactant is P and Br2, and it produces PBr3. So the number in front tells us the coefficient. So in front of P4, there's no coefficient being shown, so that tells us that's a 1. In front of Br2, there's a 6, and in front of PBr3, there's a 4. So what that actually is telling us is that there is 1 mole of P4 and 6 mole of Br2, and they combine to yield 4 moles of PBr3. So let's take a look at this example. In this example, we have Mn and Hi on the reactant side and H2 and MnI3 on the product side. So the way we read this is we have 2 moles of Mn interacting with 6 moles of Hi, and they produce 3 moles of H2 and 2 moles of MnI3.